And we said that if we want to derive the gain, that it will be basically 2 stages for the BJT cascode, but basically to have a refresher, and then we can continue with the other types of amplifier. So in the BJT cascode, we said that the cascode we can use, if you see the structure from here on, you can use those equations that we derive here. And you can use the input resistance, the output resistance, okay? Because you might see this structure in this form. For example, this is Vn, and then this is feeding another stage, okay? Maybe this is feeding another stage of a regular common emitter amplifier that is biased by another current source, okay? And in this scenario, you can calculate the gain from here to here based on those equations, and then from here to here. Now, if I want to calculate the gain from Vn to Vo for stage number 1, what did we agree we do always? We look outside my structure. Anything that loads my circuit, derivation is assuming that this is ideal. Okay, يعني R infinity. So if we tell you that this has any resistance, then you are going to lump it together with the R load that the amplifier up to point VO will see outside its own transistors. Yani we're gonna look in this direction and see what is the load that we see due to this stage 2. And if the current source is not ideal, we will put that in parallel with the load coming from stage 2. So what is the resistance that will load stage 1? Yani for stage 1, okay, my R load is equal really Rn for stage 2. And in this derivation that is in this slide in parallel with the resistance if seen at the output node. Any other resistance seen at output node. Outside the amplifier that I am studying, يعني إذا current source مكان ideal outside the amplifier that I am studying. Okay? So what is Rn of stage 2 in this example? I'm looking into the base of a BJT, and with the emitter grounded, I will see if this is Q3, I will see R pi 3. Okay, so we use this from the rules. So I'm going to go back to the derivation. The derivation says that if you see this structure with an ideal current source, then the gain is 2 gains. So this is the open circuit voltage gain لأنه ما عليه stage 2 ما عليه R load. It does not have R load, it does not have stage 2. And if we want to look at this circuit, Vin to V out, and this is a common emitter, and to Vx and Vx to V out, it is another stage with a base at DC, and this is a common base. So I can use the gains of each one of these, okay, to find the derivation. If we want to call this level 1 or stage 0, okay, if this is a stage بدنا نسميها 1 لأنه سمينا هي كلها stage 1, I can look at the gain from this point to this point on condition that I know what is the effective resistance seen looking outside. Okay, because the formula sheet tells me what is the gain if I have some resistor RC here. Okay, this is no signal again. So I need to see what is RC, and RC would be the effective resistance from the resistor sheet looking into the emitter. Okay, so to find what RC is, we go to the resistor sheet. Okay, and in the resistor sheet, we search for looking into the emitter of the BJT. Okay, so this is the rule, looking into the emitter of the BJT, and with some So this is okay. So if I am looking into an emitter of the BJT with some resistance connected at the collector, then the equation says that the effective resistance looking into a BJT, okay, so the effective resistance looking into a BJT from its emitter with the base grounded and no signal here, it is equal to, if there is if there is early effect, it's equal to R pi parallel to RC plus RO over 1 plus GM RO. Okay, so now I can flip back to my circuit, and if I want to look into this circuit, I want to find the effective resistance looking up this here. So this is my Q2, okay? And the Q2 has a resistor RC2. So this is 2, 2, 2, 2, 2, okay? And it has at its collector, if this is ideal, this is R infinity, okay? So RC2 tends to infinity, automatically infinity plus number over a number, this gives me R pi 2. Okay, so this becomes R pi 2. Okay, so فإذا now I can, to find the gain for the stage 1, which is this stage here, I have the transistor Q1, and I know that I see a resistor RC1 which is connected to Q1, whose value, pardon me, whose value is equal to what? To R pi 2. Is this clear? Anybody has any question? I'm not doing this, I'm doing this just to make sure that you know how to derive this, because it is more like a practice for the resistor sheets. Okay? طيب. Great. طيب. هلا فإذا this is how I find the gain for stage 1, and in this scenario, therefore the gain for stage 1, it's a common emitter with a resistor at its collector node. So if we go to the voltage gain sheet, the voltage gain sheet tells me that I have a common emitter. So this is the first equation for the common emitter only. Okay, يعني هذه الصورة هي للcommon emitter. Let me minimize this. Okay, so this is the picture for the common emitter. It's the first page. I don't have RS, I only have R, what they call here RD, and therefore the equation, if RS is 0, is minus GM RO over RD. So the gain is minus GM times RO parallel to whatever I see at the drain node or the collector node. They use the same terminology here, هي سموها RD. Okay, so if I come back to this sheet now, really I'm dealing with transistor Q1. So now I can say it's minus GM1 R1 parallel to RD. RD is really R pi 2. Okay, so that's how we derive those equations from the voltage gain and resistor sheets. Okay, in a similar fashion, we can derive stage 2. It has a resistor which is infinity connected to the collector. Okay, and we can find the gain for the second stage. But at least anybody has any question about stage number 1? طيب, okay. طيب, هلا لكن now, so now what we can do is we can use, for this specific type, we can use the gain. We have the gain, it is minus GM1 RO1 parallel to RO2. For the second stage, since it is loaded with R infinity, the gain is the open circuit voltage gain for the common base, and it is 1 plus GM2 RO2. And the total gain is the product of the two gains. And you can use this formula automatically if we have a problem or you have a cascode with no load on it. Okay, now the input resistance to the cascode, if we go back to the previous picture, what is the input resistance here? I'm looking into the base of a transistor with the emitter grounded, independent of what circuitry I have at the collector. What is the effective resistance? شو بيطلع?
R pi.
Okay, so this is the input resistance is R pi 1. Okay, great, excellent. So هلا لقينا we have now also what's the output resistance of this circuit. The output resistance in a similar fashion to the way we derived the cascode. Okay, it is really when grounding this and grounding this. Okay, and looking down this node. Okay, so Vn is being grounded. So from this node, I will see Ro. Okay, so it's equivalent to the problem where we saw here Ro1. Okay, and this is grounded, and I'm looking down this circuit. So I will see an Rx1 that is function to Rps plus RO2, because this is transistor Q, will say what RPS is, plus GM2 times RO1 times RPS, and RO2, pardon me, times RPS. And this is RS, and RPS is really, in this case, RS parallel to R pi 2, where RS is my RO1. Let us double check this. Okay, so we had derived this before, and now you can use it automatically if you see the cascode. يعني in a similar fashion, to the way you saw in the MOSFET case, the closer transistor I use, it's a GM, and it's RO, and it's R pi. Okay, so if we go to the, let's go to the next slide. Okay, let's go to the next slide, and let us see here the output resistance. Okay, so it is, they're saying it is similar to that of the common gate, but let me take you where RPS, يعني هيدي هي RPS, it is RO1 parallel to R pi 2. Okay, and this is, let me go to the resistor sheet because it will be much easier for you to derive it from there. So in the resistor sheet, we have the equation for the cascode. Okay, so هلا هو انتبهوا بس انه هون هو the first one is Q1 نحن مسمينه, we called it 2, and here he tells you that the effective resistance is RO for this guy, okay, plus whatever he calls the parallel resistance, which is R pi for this guy parallel to RO2 for this guy. Okay, so this is RO2, and the R pi is for the top one. Okay, and GM is for the top one as well. And this rhymes very well with the case, this rhymes very well with this case where he tells you that it is RO, then هيدا هي 1, 1, 1, 1, okay, plus RPS, where RP is R pi parallel to RS. يعني it is really the same. We're just maneuvering the wording and the letters. So always the top transistor where you are looking from, we have it's a GM, it's RO, it's R pi kick in into the equation, and the lower transistor or the lower circuit, what kicks in from it is only the RS. Okay, so that's what we need to remember in the BJT. Okay, so هلا we can use those equations automatically. We don't need to derive them. We don't need to, sorry, just 1 second. We don't need to derive them, and therefore he's telling me that R out, I can approximate it if I know, because if R pi is small, okay, if R pi is much smaller than RO, then R pi parallel to RO will be approximately R pi, okay, and then this will be equal to R pi plus RO2 plus GM R pi times RO2. So this is approximately R pi plus RO2 plus GM R pi is beta times RO2. So since R pi is small, this is approximately RO into 1 plus beta. Okay, so that's what of beta of the second transistor, and this is its R pi and its GM. Okay, so we can يعني approximate for the cascode that this is the effective output resistance as well. Okay, so the equation is written in the full form and in the abbreviated form in the circuit. So what we notice is that the output resistance gets multiplied by beta, which is 100 times. So it has a large output resistance. هلا we have the output resistance. So if we tell you it interfaces another stage such that, and a current source or something else, such that the RL prime, I have its value. It's the parallel of some resistors R1 and R2. How do I find the gain? Where do I find the gain? You have this sheet here where you can find the product of those two to give you AVO. What is the gain as function of AVO? You can automatically plug in what? Exactly. So it will be RL prime, thank you, Ibrahim, over R out plus RL prime. Okay. يعني if we go back to this complex circuit here that we have here, and we say, well, I'm going to interface this to a common emitter, okay, and in this case, and some resistor here between VDD like this, okay, هيدا الفاينل VO3, and this is Q3, and this is R1, R2. What is RL prime in this scenario? هيدي VDD حتصير ground بسمول signal analysis. هيدي صارت grounded, هيدي صارت grounded. I'm trying to find RL prime seen by this cascode in black. What is it?
R1 parallel to R2 parallel to R pi.
Exactly. So it is R1 parallel to R2 parallel to R pi 3, right? Because if I look outside of the transistor, هون عندي R infinity. Okay, and here I will look up and down and into this relation. Okay, so for this specific cascode, since the current is adding up, then the resistor is in parallel. For this specific cascode, because the derivation, okay, the derivation came out to be as function of AVO, and it is not in the voltage gain sheet. Anytime you want to find the gain, you need to say it is RL prime over RL prime plus R out times AVO. Okay, so this is very important, and honey, they derived for me AVO, which I can find it in terms of this. Be careful that when you are using the voltage gain sheets for the other three types, okay, for the basic three types, for the basic three types, the basic three types say if you have a common emitter, this is Vin, this is V out. Please identify everything seen outside the transistor at the emitter node and everything seen outside the transistor at the drain node, and plug them into those equations here. Okay, so this is the difference. هونيك عندي ال AVO, and I need to find RL prime, but it is not summarized in this sheet, and plug it in to find AV. Here they tell me all the resistors that you see at the drain node, or all the resistors that you see at the source node, find it outside my transistor, okay, and tell me what's the gain. Okay, هلا نحن نعمل practice next week on this, but I just want to make sure you're comfortable بس هيك to navigate in the voltage gain sheet. Okay, هلا the third and the last type, which is the third gain in the gain sheet, يعني عندنا ال common source, common emitter, common gate, common base. So the third node is the drain, and in this scenario I have the common drain. The only thing about the common drain or common collector is that typically the drain node or the collector node is connected to VDD, يعني it is no signal, so it is directly shorted. There is no resistance. Okay, there is no resistance for the circuit, and it relies the input, since the drain is common, the input is from the gate or the base, and the output is at the source node and effectively the emitter node. And there is some resistance, of course, loading the output effectively RS. So if there is a load and a self-resistance, I will put them all in parallel. And if we look at this specific circuit, then it is characterized by the gain. Okay, so the gain is function of RS اللي هي موجودة هون parallel ل RO, which is the resistor self RO. Okay, and then the overall gain, هلا we will derive it briefly, is function of this equation. Alpha is put so that it is for the BJT it is calculated, but for the MOSFET, or when beta tends to infinity, then alpha tends to what? It tends to 1. يعني إذا قلنا لكم we have a BJT with infinite input resistance with infinite beta, then its alpha is automatically going to tend to 1. Okay, Heidi, we don't worry about anything that says body effect. Okay, so you can use this formula to study this type of amplifier. But let me ask a question, because later we will derive it in the slides. If I ask you now, what is the output resistance for this circuit? Well, I'm going to look, okay, into this transistor. If RS is given as part of the circuit, it is not the load, then we need to count it with it. But looking up here, what do I see? Looking up here, what do I see? I will see this with the BJT, with the base grounded and the collector node grounded. Okay, so I want to figure out what is this effective resistance. Let me open the resistor sheet. Okay, let me open the resistor sheet and let us see if we know how to find this effective resistance of the BJT with its collector grounded. So where do I go in the resistor sheet? I need to look at the resistor sheet, that equation that says looking from the emitter. Okay, so this is the closest one. Sorry, pardon me. Okay, looking into the emitter of the BJT, and but this says with some resistance at the collector. What is the equation here? What is the equation here? How do I apply? How do I map this to this? They are similar.
We
What do I
set
do?
RC equal to 0.
Exactly. So أنا هون عندي resistance, but what is its value? 0. It is shorted, right? So automatically I remove RC, it is 0. Okay, so هون بصير عندي RO over 1 plus GM RO, and I plug in the equation. Okay, so this would be the effective resistance that I see. هلا when RO tends to infinity, when RO tends to infinity, okay, if RO tends to infinity, the equation becomes R pi parallel to RO over 1 plus GM RO بتصير 1 على GM, okay, and this becomes R pi times 1 over GM over R pi plus 1 over GM, okay, and in this scenario, this becomes بضرب GM up and down R pi over 1 plus beta اللي هي the equation that we see above. So RC does not really matter, and this is the little RE which we know from before, but it is really R pi over beta plus 1 for all what matters to me. Okay, so بحال RO is finite, I will use this with RC is 0. If RO is infinite, I can plug in this equation. Okay, so great. لقينا the common drain is really, now I have the drain node connected to VDD, or the collector node connected to VDD, and I am going to use it for gain purposes. طيب, let us بس هيك inspect شوي equation here. So this is, it is equal to GM O times Rs parallel to Ro over 1 plus Gm for the MOSFET times Rs parallel to Ro. This is a gain term around 100. So this is around 100 مثلا over 101. يعني the gain for this circuit is around 1. So it is really meant just to have the output be similar to the input. Okay, so it is meant to have the output be similar to the input لأن the gain is around 1. Okay, but what is the trick? What is the issue with this circuit? If I want to say what is the input resistance for this MOSFET here, شو input resistance لإله from this side for the MOSFET?
Infinite.
Infinite, yes, لأن I 0 هون. طيب what about the input resistance for this amplifier from the base of the amplifier, from the base of the BJT? What is the input resistance? Let me open, let me draw it here. Okay, so هيدا عنده gain 1, pardon me, عنده gain 1. Let me draw the circuit here so that we go to the resistor sheet and try to see what is the input resistance for such a circuit. And if we open the resistor sheet, it is going to tell me the following. So I need to find which equation. I need to be looking from the base. So I'm going to go and look from the base. Okay, and this is telling me looking from the base of the BJT. Okay, the effective resistance, if I have, let us assume that RO tends to infinity, just to make it simple for us. If RO tends to infinity, the effective resistance, independent of what RC I have here, and I have RS, okay, so heidi RC, okay, and I have RS, and this is the ground, it is equal to R pi plus beta plus 1 into RS. And of course, if I have RORC هتروح على 0, so I will end up having this equation here. So the effective resistance will be R pi plus beta plus 1 times هيصير RS RO over RO plus RS, right? And it's multiplied by this, RC equal to 0. So it will be R pi plus beta plus 1 times RS parallel to RO. Okay, so it is just plugging, and I'm not asking you to remember. We need just to know I can use this equation, and we need to know, well, RC is 0, this term goes away, but I'm trying to simplify it for you. So in both cases, RS or its effective parallel with RO, which is reasonably large, gets multiplied by beta plus 1, يعني it has a large Rn. Right, and beta sometimes is around 100. Okay, so therefore, this type of amplifier, although its gain is equal to 1, it helps me get a large input resistance. Yani it acts like a buffer because it has a gain equal to 1, but its input resistance is, pardon me, let me go to the voltage gain sheet, but its input resistance is, its input resistance is 1. So it has a large input resistance, but a gain equal to 1. And this is good in what scenarios? This is good in the scenario when, I'm going to clear this now, this is good in the scenario where, well, like we explained before for the current, if I have a small R load, okay, and I have here a circuit that has a large RO, okay, and let us say, or a large R sig, يعني, and this is my signal, I would really want to interface this with R infinity or a large Rn, right? So that most of the signal will transfer to Vn, right? And if looking into this circuit has R infinity or large R, then most of the signal will really transfer to Vn. And then this amplifier will transfer the same Vn with a gain of 1 to this R load. Okay, so instead of plugging this small R load here and having most of the signal تكون R load over R sig plus R load, if this is very large or R load is small, then I will lose it. I am going to really interface it with some Rn, which is very large. So then Vn will be equal to this much, and then the gain is 1, so I will transfer the signal to this output. Okay, so that's the objective of this circuit. هلا we don't want you to يعني عم أعطيكم الموtivation, but what really matters to me is that I know at this stage that if I have this circuit, looking into it, it will have a large Rn, and that the gain for this circuit will be based on the effective RS. هلا طبعا إذا كانت هون عندي R load external, this will be RS prime, which is RS parallel to R load, and so on and so forth. But the gain, independent of what the load or RS parallel to R load is approximately 1. Okay? Clear? Anybody has any question? So we saw how we can derive those quantities from the resistor and voltage gain sheets. Okay? So I'm going now to go back to the slides and explain it again through the slides, but a little bit quicker than if we had not seen the voltage and resistor sheets, the voltage gain and resistor sheets. So the main definition is that I have my transistor, the input is at the gate, the output is at the source, and the drain node is at DC, so it is really signal ground, and that's why we call it common drain. We also call it source follower, source meaning supply, okay, because the output becomes equal to the input and the gain is 1. So this is really, I'm just buffering the input signal. And in small signal analysis, if I want to plug in the pi model, I'm going to ground the drain and I'm going to put the resistive load here because this I'm assuming ideal. So Vn is between the gate and the ground, and Vout is between the source node and ground. Okay, so really Vn is equal to VGS plus Vout. Okay, لأنه هي بين الجيت والground, and this is between S and ground output. Okay, so this is the main thing in the derivation of this circuit. So from this, the input resistance is infinite. The voltage gain, it is really VO over VO plus Vn, يعني it is equal to VO over Vn, pardon me, but VO is equal to Gm VGS times RL, and Vn is equal to VGS plus Gm VGS times RL, okay? And now I can take out VGS, and so the total gain will be GMRL over 1 plus GMRL, the equation which we saw. Okay, so this is where the equation comes from. And then the open circuit voltage gain, if there is no load, it is really going to tend to what? When RL tends to infinity, it is going to tend to 1. Okay, so here the derivation, so the open circuit voltage gain is 1. Perfect. Okay, let's see the output resistance. We already derived it. We derived it in its many forms. In the case of the output resistance, here, what he is telling me, I'm going to draw it as a transistor, effective transistor. The gate is grounded. If RL is the only source resistance, يعني I'm going to look from this node with R infinity here. So it will be really looking up and down, okay? And I have R infinity down لأنه هو شلل RL وما عطيني ولا RS. Okay, so in this scenario, looking up, if we go to the resistor sheet, it will be 1 over Gm, and it is لأنه RO tends to infinity. Here we're assuming RO tends to infinity in parallel with R infinity. So this is the output resistance that he is saying. okay? And let me take you here, and we just went over it, right? And the resistor sheet for the MOSFET. If we go now to the MOSFET, okay, looking up, okay, in the MOSFET, with some resistor RD is equal to 0, okay? So I have RD equal to 0 here, and RO tending to infinity, then I will see 1 over GM, which is this equation here, independent of RD. Okay, so this is really what he is deriving for me on this slide. And I don't have anything here at RS. Okay, so so we remove it. Okay, so this is 1 over GM, and we can always go back to the resistor sheet and the transistor schematic to derive them. So the output resistance for this circuit is very small, and this is why most of the gain gets transferred to the output, to the load. Okay, Kamel, the output resistance here, it's just telling me how it is derived. We don't have to go through this. Okay, now he's saying I have RO, and in the presence of RO, I want to rederive things. So I'm going to rederive the gain, and the gain will tell me RL parallel to RO, because what happens? I have at this node, between this node and the drain RO, and the drain is grounded بين source و drain. شو بيصير بهيدي RO? It will fall back in here, right? I can remove it from here, and the drain is grounded, and draw an RO at this node, right? So for the gain, instead of being a GMRL over 1 plus GMRL, it becomes GMRL parallel RO and 1 plus GM parallel RO, which is similar to the voltage gain sheet that we saw before. Okay, great. Done. What about the output resistance? When I want to look at the output resistance for this circuit, I remove RL. This is ideal. So I'm going to look into it. So I'm looking into the source. Okay, with this is RD plus RO over 1 plus GM RO. Okay, now RO is finite, so I'm going to plug in RD equal to 0 and find the equation for the output resistance. Okay, so that's the only difference. يعني عطاني إنه RO is finite. So let us see what the other slides are going to tell us. The other slides are telling me that this is the equivalent circuit. I can have RL parallel to RO. And it is telling me that the input resistance is still infinite. The gain now has RL prime. And that the open circuit voltage gain is when RL tend to infinity, it is still going to tend to 1 approximately. Okay, لأنه RO parallel infinity is RO and GMRO is a large number. And then it is telling me to derive the output resistance. It will be really RO parallel to 1 على GM, لأن أنا عندي RD plus RO over 1 plus GM RO, and it will be the same. يعني if I plug this in, or if and I set RD to 0 and find the equivalence of these, I will find that it is the same equation that is given here. Okay, so you can plug whichever equation, the one from the sheet or the one from the resistor sheet, but the resistor sheet is always simplest because you look at the schematic. In a similar fashion, just like I have the common drain, I have the common emitter or the emitter follower. Why do we call it emitter follower? Because the emitter node follows the base node, and this will be effectively grounded. Now, the only difference in the emitter follower is that if we want to find R out, okay, if I want to find RO, it is simple because I will ground node Vn, and Vn is at the end of R sig. Okay, RO is when Vn equal to 0. I remove RL, this is ideal. I will look up, I know how to find this equation. Okay, but if somebody told me that he wants R out, or if I have a capacitor here looking, okay, so if somebody tells me that I want R out, which is the resistor looking into the circuit, أكيد بنشيل RL لحالة ال R out وهيدي ideal. Okay, with the V sig 0, Okay, we have the full-blown derivation here, which is slightly different from the derivation that you have in the sheet. لأنه بالشيت بتقلنا إذا عندي RB بالresistor sheet, it tells me that if I have RB, I can use the equation in a specific form. Here, بدون the complexities, automatically they tell you what it is as function of R6. Okay, so you can use the equation that is derived here. Okay, so this is the only exception where it is easier for you to find R out for this specific circuit from here. Okay, and we can go over it in practice later. Let us now see what the slides are doing. They plugged in the pi model for the transistor. They put RL between the emitter and the ground. And now we're trying to derive the current, the relations between VO and VN by stating that if I have IN, okay, I know that V pi is equal to R pi times IN. And I know that V out is equal to RL into GM V pi, which is GM R pi times IN, okay, plus, okay, and this RO will fall in parallel to, so this will be RL prime. هيدا حننزل البرانش لتحت حيصير RL prime. So it is RL prime times the sum of those two currents plus IN, okay, which is equal to RL prime. GM R pi is beta plus 1 times IN. Okay, so this is V out. So it is beta plus 1 times RL prime times Rn. And Vn is nothing but VO plus V pi اللي هي VO plus IN times R pi. So now I have all of them as function of IN. I can reduce the equations. We're not going to go through the math. بس حدا عنده سؤال كيف طلعت ال VO? Anybody has any questions? يعني نزلنا ال RO صار عندي RL prime. قلت إن it is the sum of the two currents flowing into the RL prime times RL prime. وحطينا V pi هي R pi ضرب Rn. So V pi is R pi ضرب Rn. I plug it in here. I know the total current. I multiply it by RL prime. I get VO. And in a similar fashion, Vn is the sum of those two voltages which depend on In. So now I can reduce the expressions and I can find the gain for this circuit. أول شيء, what is the input resistance? It is no longer finite. So Vn over In can be really derived either from VO plus V pi over In. Okay, or it can be derived from the equation where I have RL and I'm looking into the base of this with RC equals 0 like we did at the beginning of the class, and it will give me the same equation and it ends up being R pi plus beta plus 1 times RL prime, where RL prime is really the resistance at the emitter parallel to RO. يعني it's easier to, for me at least, I think it is easier for you to start to use the resistor sheets to derive those quantities. Okay, طيب, and then the voltage gain, if we put VO على Vn, we will find that it is equal to this. Of course, beta plus 1 times RL is much greater than R pi, and therefore the gain is approximately 1. And if I have the voltage gain, the open circuit voltage gain is when RL tends to infinity. So we can plug in from the above equation and we find that it is approximately equal to 1. Okay, طيب, and then we have, so this has a large input resistance, gain equals to 1, so the signal at the emitter follows the signal at the input, and this is why we call it emitter follower. And as far as the output resistance is concerned, we said that we can find RO easily, but if we want to derive R out, i.e. when V sig tends to 0, okay, in this case, what we need to say is we need to find Ix and Vx over Ix. So we can say that Ix is equal to minus GM V pi. We do KCL here, plus Vx over Ro, right? Plus Vx over R pi plus R sig. okay? And then I need to find Vx as function, V pi as function of Vx, right? So can I find V pi as function of Vx? Can I find V pi as function of Vx? What is the voltage at this node here? Vx. And in this branch, what does V pi comprise out of Vx? يعني إذا كلها هاي Vx قديش ال V pi منها؟ It's a voltage divider, right? Okay. So from the voltage divider, I can find the relation between V pi and Vx. بس انتبهوا للsign. The sign is inverted, so there will be a minus. And I can then find a relation between Vx and Vix. Okay. So this equation, because of the presence of R sig, it does not straightforward apply from the sheet, but we can talk about it later. Here he's finding quantities as function of the currents In, and eventually R out comes out to be this complex equation, which you can use automatically when you see the circuit like this, okay, with some R sig, V sig, okay, and some here without RL, okay, so this is only looking into this circuit, and هيدي هي ال R out. We removed RL, okay, so we removed RL in this scenario, and it is telling me that if I'm looking up here, okay, then I will see a resistance which is function. I will set V sig to 0, and I will see a resistance which is function of R sig, RO, R pi, and beta. And now, if for example you have a capacitor, okay, let's say that you have a capacitor that is sitting here with some resistor RL that is also sitting at this node, then the capacitor will see in OCTC the parallel of those two resistors. Okay, so the capacitor is going to see the parallel of RL and R out. Okay, so that's how we want to use those equations. We want to be able to say, oh, I'm looking from the emitter of a common, this is for the BJT, sorry, for the BJT, I'm looking from the emitter with a common drain amplifier, and I have a signal R sig with R sig, and therefore the resistance seen by the capacitor will be R out parallel to RL. Okay, so that's our objective. Okay, طيب, anybody has any questions? Okay, طيب, great, thank you. Okay, so I will send email for the short